Isaac Aquino's absent. Ishi.
Here.
Madison.
Here.
Sienna.
Here.
Ivan.
Here.
Alex.
Here.
Irvin Gomez.
Here.
Samantha.
Here.
Caitlin.
Here.
Annika.
Here.
Eric.
Here.
Max.
Here.
Viela.
Here.
Alexis.
Here.
Nora.
Here.
Strummer.
Here.
Strummer's out. Strummer?
Yeah, here.
Okay. Virginia.
Here.
Clara.
Here.
Giselle.
Here.
Camilo.
Here.
Ariana. Ariana's absent. Kimberly.
Here.
Emily.
Here.
Jade.
Here.
Malia.
Here.
And Seth.
I don't think that's gonna work.
What was that?
Here.
Who is that said here? Someone just randomly say it.
That's me. Don't. Why is it echo? Can you hear me now?
Oh.
Yeah.
Seth.
Yeah.
All right. Okay. Ariana. I have Ariana Silva and Isaac Aquino absent.
Isaac is here.
Okay, Isaac is here. All right. Okay, so Ariana Silva is the only one absent. 27 search 28. Here. 28. Someone's missing. Oh. Okay. All right. Okay, let's go ahead and present. Here's what we're going to do today. We're going to talk about graphing rational functions. So remember, or radical functions, which is radical exponential functions. And here we go, share my screen. Okay. Okay, go ahead and that's what we're going to do is assignment number 24, 4.3, graphing radical functions, page 212, 3 through 31 odd, 51 through 61 odd, name, date, period, and math 3 honors. Make sure you have a straight edge, I think, right? We did a lot of graphing today. Has to be on graph paper, of course, like all the other assignments. But this one in particular. Okay. Let's see. I wanted to show you guys something. Wait, what's going on here? Want that? No. Where'd all my windows go? I'm trying to find. Well, all my windows disappeared? Oh, what's this? Okay. Okay, that's weird. Open a whole new window for that? Huh, that's interesting. Okay, so, all right. Okay, here we go. There we go. Okay. So let's look at the canvas real quick. A couple things I wanted to make sure you guys see, because I wanted to remind you, if you're ever absent, remember you can go to this class meet records, and it'll take you to the modules where all my class meetings are. So it'll get there, let it wait for a second, and then there you go, like Unit 4. This is what we did yesterday. Here's my Unit 4 video, and you can watch, watch the Unit 4 video. Lesson 4.2. And then I'm recording this one. You can see that. Anything you guys miss. So all of those are there. All right. But let's go ahead and look at today's assignment. Actually, a couple things that you must know how to graph before we do this. Let's go over some basic graphing functions. We're on 4.3. Now there's an answer key too for the self-practice if you want to go over that. So 4.3. Okay, so what do I want to graph here? Let's first graph for our notes. What we're going to call is the square root function. Okay. Okay, the square root function. Okay, so the square root function is going to look like this. Y equals the square root of x, or f of x equals the square root of x. That will be our parent function. Now, a couple things. What you're going to need to do, a couple things you have to remember with the square root. First of all, can you get the square root of a negative number? Right? So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, can you get the square root of a negative number? So if I said, well, first of all, let's do a table for this. And we only want to plug in for our x's numbers. I mean, we can plug in any number that we want for our x's, x, y. Like, let's start with -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay. Now, let's say we plug in -4. Can I get the square? So what this means is I plug in -4 into my x. Can I get the square root of -4? No, the answer is no. We technically cannot graph it. We would say that it could be square root of 4 times square root of -1, which would be 2i. But we can't really graph I functions for now, right? We can't graph them. So we cannot get the square root of a -4. We can't get the square root of -3, can't get the square root of -2 or -1. Can't get the square roots of those, right? Because the square root, you have to find two numbers that multiply and equal that number, right? So, but can we get the square root of 0? Yes, the square root of 0 is 0. Okay. Can we get the square root of 1? Yes, square root of 1 is 1. Can we get the square root of 2? Yes, but it's a fraction, like 1.4. I don't really want to. I'm just going to say not now. What should I put here? I'll say no, I don't want to. Square root of 3? No. Can I get the square root of 4? Square root of 4 is 2. Now, it could be positive 2, it could be negative 2. But when we get the square root of functions and we're graphing it, we're only going to graph the positive. We're only going to graph the positive. Now, I don't want to square root of 5. No, I don't want to get the square root of 6. I don't want to get the square root of 7. It's too hard. I don't want to get the square root of 8. Nope. Square root of 9. Yes, because square root of 9 is 3. Okay, so now let's look at how this is going to look on our graph. Okay, 0, 0. Square root of 0 is 0. I go over 1. What's the square root of 1? 1. Square root of 2. I don't know. Square root of, I don't care. Square root of 3. I don't know. I don't care. Square root of 4 is 2. Square root of 5, 6, 7, 8, 9. 1, 2, 3. Okay, so there's my square root function. It'll look like that. That is f of x. Okay, there's my square root function. Now, am I teaching you guys? Okay, you guys are still there. Okay, now, you are going to have to be able to list the domain and the range. Domain and the range. Okay, so generally, by the way, our parent function of f of x equals square root of x is going to look like that. It's just going to look like a line that goes this direction. What's my domain? Domain is my x from here to here. Now, if you notice, my function is not in the negatives, but it starts at the zeros. It starts at 0, and then it goes on forever. In this direction, domain is x is greater than or equal to 0. What's my range? Notice we are not graphing any of the negatives because we're just not doing the negatives, so we don't any zeros. So my range is y is greater than or equal to 0. So make sure you understand the domain and range. Those are going to be test questions. And that's that. Are there any questions on that? Okay, I'm going to move on. We're also going to have to graph. Oh, actually, I'm not moving on. Now, that's my parent function, but remember, we can also do our parameters. F of x equals a times the square root of x minus h plus k. There are my parameters, where a is the stretch, h is the horizontal shift, and k is the vertical shift. So if I told you to graph f of x equals square root of x plus 3 minus 1. If I asked you to graph that, okay, I'm going to ask you, where do you think, let's say right here is my vertex. That's my vertex. Where would my vertex be for that? Okay, where would my vertex be for f of x equals square root of x plus 3 minus 1? I want you to think about that. Where would my vertex be for f of x is equal to the x square root of x plus 3 minus 1? Where would my vertex be? Okay, where would my vertex be for that? Okay. Where would my vertex be for this? Ready? Okay, Annika, what'd you get? What's my vertex?
-3, -1.
Correct. -3, -1 is my vertex. So that means I go 1, 2, 3, down 1. It would be right there. There's my vertex. Now, I'm taking the square root of my numbers. We could do a table. However, remember, once I get my vertex, I just get the square root of my numbers. If I go over 1, what's the square root of 1? 1. I go over 1, 2, 3. I don't want square root of 3. 4. I can get square root of 4. Square root of 4 is 2. So I go up 2, square root of 1, and then over 9. So here, the same thing. I can go over 1. What's the square root of 1? 1. What's square root of, move over 2? 1, 2, what's square root of 2? I don't know. Move over 3, what's square root of 3? I don't know. What's the square root of 4? Square root of 4 is 2. That means to go up 1, 2. Be right there. And then go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 1, 2, 3. I should have called this g of x. But anyway, that's your square root of x plus 3 minus 1. So anyway, that's generally how we're going to graph it. The other graph, I'll leave that there as you guys are graphing that. Give you about 10 seconds to finish it up. Okay. 5 seconds unless someone needs it. 4, 3, 2, 1. Okay. Other things we're going to have to know how to graph, if you guys see, will be the cubic function and the fourth root function. Okay, now generally when we're going to graph these, we're just going to do a table. Okay, we're just going to do a table for these. So I'll show you how to do them. So let's go ahead and do our pair deck lesson here. So I got a little link here for you. See how you guys do. Okay, go ahead and link it up. Okay, so we're doing paired. I'm gonna do your homework with. So do this as your homework, but then I also want you to respond with your answer on the pair deck, right? So we're gonna start with number 3. Okay. So first function. How many people are on it? You can draw this. See if you can draw f of x is equal to the square root of x plus 3. Get that on your pair deck function. Go ahead and graph that. F of x is equal to the square root of x plus 3. I'm going to draw my answer on my graphing paper. Now, you can do a table if you like. Remember, you can't get the square root of a negative number, but that is shifted. So we can get the square root like all the way up to negative 3. Okay, let's check out some of your responses here. Oh, can we not draw on this?
It's hard to
there.
zoom in.
Oh, yeah? Look, someone got dots there. This is, oh. I mean, you get a general idea. I mean, it doesn't have to be pretty. Just draw, just graph a rough graph, right? Okay, I see someone like here, right here. This is a good graph. I like this one. Let me present it. Just do the best that you can. So this minus 3 here means we're going to go to the left 1, 2, 3. And so this one right here is perfect. And look, they got the dots. Go over 1, up 1, over 1, 2, 3, 4, up 2, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. Whoops. Did that just delete? That was a good one. That's a good one right there. Just do that. Look at this person's doing great. This is all I want to see is just get the idea, right? -3, square root of 1 is 1, square root of 1, 2, 3, 4 is 2, right? There you go. Look at that. That's perfect. And they got the dots. I guess you're able to put dots on there. So those of you who are able to figure out the dots, good for you. See this one, this person started yeah, there you go. See, even though they're off, I see what they mean. They're trying to get the best they can. This, you know, it's at -3. We go shift to the left, -3. That's number 3. Okay, so good. Look, great. This is perfect. Look at that. Okay, just do the best that you can. See, I got -3, over 1, up 1. Now this one just went a little low, probably just had a hard time drawing. But, you know, as long as the main thing is you're getting the idea here. Nice, great. That's number 3. Okay, perfect. I mean, not perfect, but you understand. That's the whole point of this. Okay, let's look at the next one. Okay, now graph this one. Square root of x plus 4. Square root of x plus 4. Square root of x plus 4. Okay, so graph that. That's number 9. So you guys still have to do 7 on your own, but I just want to do 9 there, or because we have to also figure out the domain and range of this one. So that's a big thing. I want to make sure you know how to do the domain and the range for this. How to do the domain and the range. Have any? Okay, take a look what you guys got. So now this plus 4 is actually, let's see if I can get a response here. There you go. This looks good right here. This plus 4, what's it going to do? There you go. This is a good one here. They just drew it. Okay, good. I see someone's changing. They see it's okay if you see your mistake. Fix your mistake if you see your mistake. Right, you go here. Then, oh, that was, there's like this one's good, right? This plus 4 means we shifted up 4. Then you go over 1 with square root of 1, 1. Over 1, 2, 3, 4. So at this point, I just go 1, 2. You should have a point right there. You just raised it a little bit. Whoever, I don't know if you know who did this, but this person just raised it up just a little bit much. Now you've got to do the same thing right here. Square root of 1 is 1. Square root of 1, 2, 3, 4 is 2. Then you go over 9 and go up 3. This one's good. Just got to connect it. Perfect. Look at this one. Square root of 1 is 1. Square root of 1, 2, 3, 4 is 1, 2. Nice. Okay, looks good. See, this one, I think this is just a little drawing error because it's so hard to draw here. I think we all know we don't start over here. We start at this point right here. We don't go in the negative, but good. Good. It's just hard to draw. I get it. Okay. Up 1, over 1, 2, 3, 4, 1. See, this graph is all like weird, but I can see the points that this person knows what they're doing. They know what they're doing. Okay? So these are great. Now, here's the next question. For that graph, which I have, see it, look at my graph, it's terrible. But list the domain and range. What is the domain and range of this? It does go on forever in this direction. You have to list the domain and range. This is a test question. Remember, domain is my x value. Range is my y value. Domain is how far is it going left and right. Range is how far is it going up and down. Okay, what is my domain and what is my range? List the domain and range. Am I talking to air? Make sure I'm not talking to air. See if you guys are there.
Wait, how do we do like greater than or equal to signs on the computer?
Can you do underline? You do
Well,
the
I can do like
let's
I can
see.
do
I'm gonna do
like
it here on the chat. Go like this. Oh, you can't do. Can you do Control U? Oh, what did I just do? Isn't it? Oh my gosh, that's crazy.
it's just the source code for the
Oh,
computer.
so you could go like this, for greater than or equal to. That good, Ivan?
Yes, yeah, it is. It's good.
Okay. Ooh, look, someone knew how to do. Who did that? You know how to do it with the line underneath. Noise. Remember, range is Y. Mm. Okay, I'm gonna write down so because I can't see the so X is equal to 0, Y. Okay, let's check it out. Let's see what we got. Let's look what you guys got. Okay. All right. Remember, range is Y. So that's only a little mistake there. This looks good, except the range is to be Y. Domain. This is saying is X is less than or equal to 0. That means it's going to be negative. We want perfect. Greater than or equal to. And don't forget range is Y. And this should be greater than or equal to. Domain. X is greater than or equal to 0. Y is greater than or equal to 4. Yes, very good. Ooh, we got the little line there. X is greater than or equal to 0. Y is greater than or equal to 4. Very good. Yeah? Good. Positive 4. Good, good. All right. You guys got it. Nice. Love it. I like it a lot. So you want to see that movie with Napoleon Dynamite? He likes ligers. It's kind of cool. Okay. Make sure you can get that.
I have a quick question.
Is it about Napoleon Dynamite?
Sadly, no.
No. Then I don't want to answer it.
uh, so isn't it like a kind of like a general rule? Whichever way the arrow points, that's the way the greater than or equal sign is pointing. Isn't that like a general rule?
That's one way you can look at it. It's not really a
Or no?
reliable source, or it's not. Let's see. Yes, Ivan, yes. However, it doesn't really show that you're understanding what's going on. But if it works
Okay,
for
yeah.
you, I will not know what's going on through your brain. Yes, as the arrow, as it goes to the right, you're going to do the greater than sign because it's pointing to the right. Is that what you mean?
Yeah,
Yeah.
I think.
What about going up though? That's for X. For Y though, I think does it work for the Y? I don't think it works for the Y.
I don't know. I was just putting something out there.
It works for only horizontal.
Okay.
But yeah. Yes, yes, yes. Okay, I'm moving on. Okay, let's see. What the son of a mother? What the heck? For this one. Okay. Can we do this together? This one's really not that hard. Well, this one will be kind of this is a crazy one a little bit because of that fraction there. Let me present. So when you see something here, that couple things that you're thinking, right? You're going to divide your whole answer by 1/5. Okay, so we have here g of x equals 1/5 times the square root of x minus 3. Okay, so we have this here. Now, can you guys see me? Am I presenting? Or is it blank? Okay, I think you guys can see me. Alex Mendoza,
Yeah,
can you see this?
yeah, I can.
Okay, cool. This means our answer is going to be divisible by 5. So there's a couple ways we can do this. What I'm going to do is I'm first going to show you the table, okay? So here I'm going to draw my graph here. Also, my other question before I do, oh, that's a terrible line. My 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. First thing is, what is my vertex? My vertex is going to be 3, 0, right? So I go 1, 2, 3, 0 right there. That's my vertex. My vertex is 3, 0. But what's my next number going to be? So let's do a table. Now, based on my vertex that I see here, what number should I start with my x's? So I know it's going to start right here. And I know it's going to go in this direction because that's what my square root functions look like. So it's not going to go in this direction. So I'm not going to start with 1, 2, or 0. I'll start with this number of 3. And then I will start with 4, then 5, 6, 7, 8, 9. However, the thing is, remember, I want to get numbers that are the perfect square roots. So that'll work. This will work because it's like square root of 1 is 1. 1, 2, no. 3, no. 4. If I go 4 over, that should work, which is 7. So let's skip 5 and 6 and just get 7. You can do 5 and 6 if you want, but you'll just get ugly numbers. What's another perfect square root? 1, 2, 3, 4. Okay, right? Is that right? 3, 4, 5. 5, 6, 7, 8, 9. So this point right here, which is 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's skip all those and let's just do 12. Okay? Because those are going to be my perfect squares. You'll see what I mean by that in just a second. Let's plug in 3 into our equation. Okay? 1/5 of square root of 3 minus 3. Right? What's 3 minus 3? 0. Square root of 0 is 0. 1/5 times 0 is 0. So I got here 3 is 0. Let's plug in 4. 1/5. Square root of 4 minus 3. What's 4 minus 3? Well, that's 1. 1/5 times 1 is 1/5. And you just keep going. 7. I said 7's a good number. 7 minus 3. 1/5. What's 7 minus 3? It is 4. Square root of 4 is 2. So that's going to be 2/5. Oh. 12. 1/5. Square root of 12 minus 3. 12 minus 3 is 9. 1/5 times 3 is 3/5. So those are my numbers that I'm going to use. Sorry, I'm able to see my calculator. Now, what's that going to look like as a graph? Well, I go 3, 0, I go 4 1/5. So it's going to be really low there. 1/5 is probably a guess. I've got a guess it's right about there. 7 is 2/5. 4, 5, 6, 7. 2/5 is there. And then I know 12 is going to be 3/5, which is just above the halfway point. My graph is going to be super duper low. That's going to be hard to graph on your pair deck. But look like that. Is anyone getting this? No one? How about this? Don't say anything if you understand. Oh, cool. You all understand. I'm the best teacher ever. Love it. Okay. So on the pair deck, so this will be hard to graph on the pair deck, but you guys can list the domain and range. Go ahead and list the domain and range of that function. I will show you there. You can look at my graph or look at your graph. What's the domain and range going to be? Can I zoom it in? Oh, oh my gosh. That's an unnecessary zoom. Okay, let's see what you guys got for your domain and range. It's actually that 1/5 should not throw you off too. I mean, it might throw you off, but you'll see it's really no different. Okay, x greater than or equal to 3, y is greater than or equal to 0. First answer is correct. 12, not sure where the 12 came from because we're starting at 3 with the x. Yep, 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 yep. Deleted, deleted. Yep, yep. How do you get the line underneath like that? There's another line underneath. How do you do that?
Just look it up and then copy and paste it.
Oh yeah, the copy and paste technique. That's a beautiful technique. Let's see, only 9. Let's see who did not respond. I'm gonna get you guys. I'm looking at who didn't respond. Better respond before I check my dashboard. Let's see who's being lazy. Maybe they're sleeping. Caitlin, are you there, Caitlin?
Yeah,
You having trouble with the pair deck?
a little bit.
Oh yeah. How can I help you?
Mm,
Caitlin, can you hear me?
Yeah,
How can I help you? What's your question?
I don't really have a question, but
But how come you're having trouble with the pair deck?
mm,
Hey, talk to me after class, okay?
mhm.
All right. Alex Garcia. Alex, are you there? Is Alex absent? Alex, I think I'll mark you absent if you don't respond, because I don't think you're here. I think Alex is gone. Okay, Alex, I'm marking you absent. So I'm gonna let Alex know that he's not here. So I have to check on it after class. Okay, Alex Garcia. Where's Alex? Look at Alex. He's just a blank chair. Poor guy. All right. Max, are you there?
Yeah.
All right, cool. All right. Okay. Let's go. Let's do this. Let's do some other problems here. What are my problems? Okay. So the rest is, let's just do some. There we go. All right. So that was, what number was that last one we did? So let's just go ahead and start graphing these. What was that last one? 1/5 x minus 5. The rest is just graphing. I don't know. Should I? Do you guys want to just do this? $13, $15. I don't know. Let's do 15. Do you guys?
Do we?
I don't know. Do you guys just want to do this on your? Let's see. You guys just got to plug in the graph and go. So let's see. We have 15 to 31.
Will there be
It's just
any cubed functions or no for the graphing?
Let's see if we can find one. Let's see if we can find. Let's do 17. There's a fourth root. And I think most of these, you guys, I think I'm like kind of like this is a choppy lesson because I'm like thinking that you guys can do most of this. But I'll do 17. You guys can do it with me. 17 is h of x is equal to negative fourth root of x. Okay, so basically you want to just take the fourth roots of numbers. That's what we want to do. You guys looking at 17? Go and write it down. I'm writing it down. I'll be presenting here in just a second. You don't really even need to do a table with this, but I'm going to increase this by, whoa, let's go 2, 2, 4, 6, 8. Is that enough? 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. All right, here we go. Okay, so I have here, let me zoom it out. Look how I did my scaling in twos. Okay, so let's go ahead and do a table here. Our table is going to look like so. And the only we want to be able to get numbers that you can get the fourth roots of, right? X, Y. So, and then we're going to make it negative. So I can get the fourth root of 0 because 0 times 0 times 0 times 0 is 0. I can get the fourth root of 1 because 1 times 1 times 1 times 1 is 1. 2, no. 3, no. 4, no. 2 times 2, 4, 8, 16. 16, I can get the fourth root of 16. And then, which I'm not going to be able to fit the next one, but 3 would be 81. Forget that, man. That's huge, right? because if I take the fourth root of 0, it's 0, because 0 times 0 times 0 times 0 is 0. Fourth root of 1 is 1, because 1 times 1 times 1 times 1 is 1. Fourth root of 16 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. And then 81 is 3, but I'm not going to be able to fit 81 in here, so let's go. We got, oh, but forgot. We're taking the fourth root of negative x. So all of these numbers are going to be negative, because that's going to make it negative, right? So then we can just go ahead and plot it. 0, 0, 1, 1, 1. So I go right there, because I don't have ones. 16. 2, 4, 6, 8, 10, 12, 14, 16. And I go, oh, shoot. I did that wrong. What did I do wrong? Someone tell me what I did wrong on my graph.
You graphed positive y's instead of negative y's?
Very good. So I want to go here, and then I got my positive x is 1. My y is going to be negative 1. It's going to look like that. Look at that. And then 16, 2, 4, 6, 8, 10, 12, 14, 16. And I'm going to go down to, which will be here. And so my graph will look like this. Look like that. And then you should be able to list the domain and range. Domain is x is greater than or equal to 0. Range is y is less than or equal to 0, because I go in the negative direction. Okay, any questions? That's 17. Okay, let's look at 19. Okay, describe the transformation. Okay, so what's the transformation going to be? It's going to be shift left 1 up 8, right? What's the transformation for this going to be? Shift right 1, vertical stretch of 2. But we'll just do the odds. What's the transformation? Remember, we got this negative here? We did that on the last one. That's going to flip it under the x-axis, right? And this is going to bring it down 1. Okay? This one with the negative here, that makes it, that's actually going to flip it 23. Let's look at 23. Okay, 23. Okay, 23 listed like this. Negative x to the 1/2. What that means is this. It'd be better to see it like this. G of x equals 1/4. Wait, what would that be? Oh, minus. What the heck? Is that right? Did I write that right? Oh, shoot. I forgot the parentheses. Big deal. Okay. That's better. 1/4. Okay. Times 1/2 is the square root of x. Okay. Now, what this does, when the negative's inside, it's going to be a horizontal flip. It's going to flip across the y-axis. It's going to flip across the y-axis. Now, let's see what that looks like so you guys can understand what's going on. By doing a table. And then the 1/4 will be a 1/4 compression. So x, y, we only want to get perfect. So what that means is the numbers I have to put in here can only be, remember we can't get the square root. I know you're saying, Sensei, we can't get the square root of a negative number. Oh, yes, we can. If I put in 0, let's plug in a negative number, -1. Now I can plug in my negatives because a negative 1 is a positive 1. Now I don't want to put in 2 because I can't get square root of 2. I don't want to put in 3, can't get square root of 3. So I can put in -4. I can put in -9. I can put in -16. Okay? So let's plug in those numbers. 1/4 square root of -0 is 0 is 0. 1/4 times -1, right? Plug in -1 there. -1 is +1. Square root of 1 is 1, and that'll be 1/4. Plug in 1/4 square root of -4. -4 is +4. Square root of 4 is 2. 2 times 1/4 is actually going to be 1/2. 2/4, 1/2. And then plug in -9, 1/4. Let me know if I'm going too fast. -9 is +9. Square root of +9 is 3. 3 times 1/4 is 3/4. And then 1/4, can you guys see that? Times square root of -16. +16 times 4 is 1. Okay, so remember we said it's gonna flip across the y-axis. So we have here x, y. And I have here 0, 0, -1, 1/4. So it'll just be up here. See how it's on the other side of the y-axis? Because now I can plug in my negative numbers. That's what's going on. -4, and then 1. This 1/4, then -4 is 1/2. This is 1/4. That's 1/2. And then 16, which I can't fit. Don't have room for it. So it's going to look like that. Domain is x is less than or equal to 0. Range is y is greater than or equal to 0. Okay. All right. I think that'll be it. Let me see if there's any others that you guys might need to do. 31, and then that's up to 31. And then we go 51 through 61. '51 through 61 says use a graphing calculator. So you can use Desmos to identify the vertex here. So just plug that in with Desmos. You should be good. That's it. Make sure you use a graphing calculator or Desmos through 51 through 61. Okay, that's all you should be able to do that on your own. All right, are there any questions? Okay, did Alex Garcia show up?
Yeah.
All right, stay after class, Alex. Okay, everyone else, you are welcome. If you don't have any questions, you are welcome to go. And I'll see you tomorrow. There's no check for understanding. Bye, Giselle. Bye, Annika. Bye, Max. Bye, Jade. Bye, Samantha. Bye, Seth. Bye, Camilo. Bye, Isaac. Bye, Virginia. Bye, Madison. Bye, Malia. Bye, Viela. Emily. Bye, Michael. Bye, Irvin. Bye, Ishi. Bye, Ivan. Bye.
Bye, Mr. Sanchez.
Who's? Bye. Okay. Before I talk to Alex and Caitlin, what are the questions? Any questions?
How do we find the domain and range again?
Stromer, did you ask that?
Yeah.
Okay, real quick, domain and range. So for any ones that I have here, right, like the domain, the way I remember domain, it starts with, okay, domain goes with X, range goes with Y. If you think alphabetical order, X comes before Y and D comes before R. So domain is X, so it's left and right, Strummer? So if you look at this
Are you
graph, am I not presenting?
No.
If I present this, if I look at this graph, right, domain goes with X, range goes with Y. So domain, the X, goes left and right? So you look at the graph right here going left and right, you can see it starts right here and it continues this way. It starts at 3 and gets bigger. X is greater than or equal to 3. Now my range goes up and down. So up and down, you can see it starts right here at 0. And even though it's growing very slowly, it is still growing. It is still continually going up forever. And so it's always going to be greater than 0. Stromer,
Yeah, I'm here. Sorry, I thought I was unmuted.
that makes sense?
Yeah, that makes sense.
All right.
So if it were to, so if the x is greater than or equal to 3, if it were to go the other direction, would that make 3 greater than x?
If it was going in this direction here,
Yeah, the opposite direction.
that would be X is less than or equal to 3, because it's everything less than 3.
Mhm.
And it's kind of like what, for the X's, it's kind of like what Ivan said. If it's going in this direction, you want to point the arrow in that direction. If it's going in that direction, you want to point the arrow in that direction. It's kind of a crude way of thinking of it, and I don't like thinking of it that way because it doesn't work for the Y, and you really don't understand what's going on. You could just say, hey, it's all my numbers less than 3. And so my X is all going to be less than 3. All my numbers are going to be X. They're all going to be less than 3.
Yeah.
All right. Is that cool?
Yeah. Thank you.
All right. You're welcome. All right. Let's start with Caitlin. Caitlin, what happened? Did you not understand? Because I can explain this stuff for you if you don't understand the domain and range.
Oh no, it's just I'm helping my brother too, so I couldn't really do the paradox.
Okay.
Yeah, he
That's a
probably-
good excuse. Okay. So is this going to be happening a lot? Are you always going to be helping your brothers, just so I know?
No.
Just today? Okay. If you ever have, if that's the case, just, I don't know, somehow let me know. Or just say, like if I say, hey, what's the matter, Caitlin? Just say, hey, you remember we talked about Mr. Sanchez or whatever? That'd be fine.
Okay.
If you feel embarrassed about telling me that you're watching your brother over the class. But that's good. That's a good excuse. Okay. So that's good that you're helping your brother. I'm sure your parents appreciate it. How old is he?
Yeah. He's my he's 15.
Oh, he's not that much younger. So you go to OHS?
He used to, now he goes to charter.
Oh, okay. All right. Well, do you have any questions then?
No.
All right. You can go if you'd like.
Okay.
All right. Have a good
Bye.
day. Alex, what happened to you?
I went to go make oatmeal, so I went to the garage to get the oatmeal, like the big old box that we get it in. And I realized my fish had babies, so I had to get them out before they got like sucked up by the filter and all that.
Your fish had babies?
Yeah, they do all the time. That's why I took them out so that they
What do you
stop.
mean that? What do you mean that babies all the time?
There's so many of them that they're always having babies.
What do you do with the baby fish?
Oh, they just grow up. I'm on like the third generation, at least, in the fish tank.
But when you get them out of the tank, where do you put them? Is what I mean.
Oh, I had another tank because I don't want them to keep breeding like that. So I took all the female ones out and I put them in a smaller one.
How do you know if they're female or not?
They have the tail's different. For one, it's really pointy for the guys, and then for the girls, it's like big and wide. But the girls are way bigger. The fish, you could just tell.
Oh, really?
I don't even have
Oh,
to
that's.
look.
Is this like a hobby or something that you do with fish?
Yeah.
Oh, that's cool. All right, I was wondering where you went, so that's why I kept you after class because you weren't. So that okay, that's fine. Just wanted to know if you're with us. How much class did you miss?
Not that much.
All right.
Max 10 minutes. I got most of the notes that you did.
All right, dude. Sounds good to me.
All right. Thank you. Bye.
All right. Do you have any questions?
No, I'm okay.
All right. I'll see you tomorrow.
All right. Bye.
Okay. All right. Bye.